Now, our first theorem is formed this way. So we have 2 points here. Now, the angle formed at the circumference here, and then there's an angle formed at the center here. The first theorem says, let's say theorem 1, shows that the angle at the center is twice or 2 times. It's twice the angle subtended at the circumference. So meaning that if you have an angle subtended at the circumference like this and an angle subtended at the center like this. So if this is 30, the one at the circumference, the one at the center will be 60. So meaning that if you have it like this, let's say this is x, that means this will be 2x. So it's always, the angle at the circumference is always smaller than the angle at the center. And the angle at the center is actually 2 times the angle at the circumference. So that is the point. So sometimes you will see it expressed as this. Let me clean this one. You will see it expressed as the angle at the center is equal to 2 times angle at the circumference. Okay, so this is how you see it most times. So if this is A, and this is O, and this is B, and this is P here at the circumference, that means AOB is equal to 2 times APB. So that is the point. So anytime you see, maybe here is 50 degrees, the one at the circumference, 2 times 50 degrees will give you the angle at the center, 100 degrees. My pen is having issues. 100 degrees. So that is the point of theorem 1. Well, there's a proof to this, but we're not looking at that today. And what about theorem 2? Now, theorem 2 says this. If you have angles formed in the same segment, so one of these is an angle at the circumference, okay? Here, subtended at the circumference. But also from this same point, having this arc, you have another angle formed here at the circumference. So back to this arc also, back to the point, let's call this A and let's call this B, also an angle subtended at the circumference. The second theorem, theorem 2, says that angles formed in the same segment are equal. So meaning that if this is A, then this is A. That is the point. So they are equal. That is the point. You can also see something like that, maybe looking like this. There may be another one here. So if this is 20 degrees, these also will be 20 degrees. That is the meaning of this theorem. Okay? There's also a proof of this, but we are not mentioning that today. Now, what is the third theorem? And the third theorem actually looks like this. So let's say we have an angle drawn in the center of the circle, the diameter. Let's call it O. Now, this theorem shows that any angle you draw from this, any triangle you draw from this center will always be 90 degrees. So no matter what side or way you draw it, so it is from the center, any way you draw it will always be 90 degrees. So this is 90, this is 90. As far you draw a line in the circle, in the center of the circle, and then you draw another angle, it will always be 90 degrees. So the angle, the theorem 3, shows that the angle in a semicircle is equal to 90 degrees. It's always 90 degrees. Okay? So when you see something like this in a problem, you should be able to recognize it when you're solving circle geometry problems. When you see something related to this, you should know that that side here, that angle formed here, is 90 degrees. And you'll be able to know that clearly when they, in the question, tell you that there is a line drawn at the center, and then there's other angle formed here. Or you could easily see that with the line drawn at the center and maybe a point here to indicate that this is the diameter.